Ever wonder what really makes your favorite games just work? You know, you click the icon, the world loads up, but there's this incredible, invisible layer of software sitting right between the game itself and the hardware whirring away inside your PC. Well, today, we are pulling back the curtain on that very magic.
I mean, really think about it for a second. There are just countless combinations of graphics cards, processors, operating systems, you name it. So how in the world can one game, made by one developer, run smoothly on your beast of a gaming rig, your friend's laptop, and literally millions of other unique machines out there? It's a massive, massive problem of diversity.
Well, the answer is actually a super elegant solution. You create a universal language, a language that lets software talk to hardware without needing to know every single specific detail about it. And that, right there, is precisely the role of a graphics API.
So an API, that stands for Application Programming Interface, is basically a universal translator. We call it a high-level abstraction, which is just a fancy way of saying it hides all the messy, super complicated details of your specific graphics card. Instead, it gives developers a nice, standard, simplified set of commands to work with. Super convenient, right?
And here's the crucial part. A developer can write a super simple, human-readable command like, hey, draw a red triangle right here. The API then grabs that simple instruction and translates it into the incredibly complex, super-specific machine language that the physical hardware actually understands. It's the difference between just ordering a coffee and having to explain the physics of steam pressure to the barista just to get your latte. One is way easier.
Okay, so let's actually follow the journey of a single command. Every single time a new frame pops up on your screen, boom, 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 a command has just gone on this incredible lightning-fast journey, from the game code all the way to your monitor. And this all happens in a tiny fraction of a second, again and again and again.
So it starts with the application, the game, issuing a command. The API catches it, gets it all structured, and then passes it along to the graphics driver. Now, think of the driver as the expert translator for your specific graphics card. It takes that general API command and converts it into the exact machine code your hardware needs. Finally, the GPU gets that code, does all the heavy lifting, the intense calculations for every single pixel, and bam, it sends the finished image to your monitor. And remember, all of that happens 60, 120, maybe even 240 times every single second. It's insane.
All right, now, for a long time, there have been two major players in this space, kind of like two dominant languages for developers to choose from, OpenGL and DirectX. And they really do represent two very different philosophies on how to get the job done.
So these two have fundamentally different ways of thinking. DirectX, that's Microsoft's baby, it's built from the ground up for Windows and Xbox. It thinks in terms of software objects, which means you create these specific graphical rules and then attach them to things whenever you need them. OpenGL, on the other hand, is governed by a neutral tech committee, the Kronos Group, and it's designed to be multi-platform. It uses what's called a state system. The best way to think about it is like a light switch. You turn a setting on, say the color red, and now everything will be drawn in red until you explicitly turn it off. This makes OpenGL super flexible for apps that need to run everywhere, while DirectX is pretty much the go-to choice for those big Windows-exclusive games. But of course, the API doesn't work alone. It's not a solo act. It's part of a much larger ecosystem. A whole team of players that all have to work together perfectly to get that final image from the game's code into your eyeballs. First up on the team, you've got the application developer. These are the directors, right? They're the ones writing the script, using all those API commands to build the incredible 3D worlds and visual experiences that we get to enjoy.
Next, there's the operating system, your Windows, your Mac OS, or Linux. If the developer is the director, the OS is the stage. It determines which APIs, which languages are even available. So if you're on Windows, you can use DirectX. But if you're on a Mac or Linux, well, DirectX isn't natively supported, which is why OpenGL is often the go-to choice there. And then comes the real unsung hero of this whole operation, the graphics driver. This is that expert local translator we talked about. If the API is the universal language, the driver is the one who knows the specific local dialect of your NVIDIA, AMD, or Intel card. And this is why you're constantly having to update your drivers. New games come out, they use new API commands, and your driver needs that update so it knows how to translate them. And finally, we have the GPU, the graphics processing unit. This is the hardware. This is the star of the show, the powerhouse actor that takes that final translated script from the driver and performs the billions, literally billions, of calculations needed to actually draw the pixels on your screen. It is the final crucial link in this incredible chain.
But there's a catch. This whole system of high-level APIs, this focus on making things simple and easy for developers, it comes with a trade-off. It's a constant balancing act between making things easy and squeezing out every single last drop of performance.
You see, each of those convenient translation steps, it consumes a little bit of processing power. We call this overhead, and it can actually limit your maximum performance. Plus, developers become super dependent on the quality of the driver. A buggy driver can crash a perfectly good game, no fault of the developer. And with something like DirectX, you're kind of locked into Microsoft's world. But maybe the biggest thing is, by hiding all those messy details, these APIs prevent developers from getting that total, fine-grained control of the hardware for that last little bit of peak optimization.
And this exact trade-off, this is why you hear so much about the newer, low-level APIs in modern gaming, things like Vulkan and DirectX 12. They basically get rid of a lot of those automatic translation steps, giving developers much more direct, to-the-metal control over the hardware to really boost performance. The catch, of course, is that they are way more complex and a lot harder to use. So this leaves us with a really fascinating question for the future of software and game development. As our graphics cards get more and more powerful, where do you draw the line? Is that ease of use, the simplicity that allows more creators to build amazing things, is it worth sacrificing that last ounce of raw, unbridled performance? It's definitely something to think about next time you boot up your favorite game.